And now it's time for us to address the problem of more complex conditions. We will take a brief look at compound conditions, although you won't actually be using these until the last program in the semester. As a result of needing more complex conditions, we will take a look at the nested selection structure. Let's start with the problem statement. It's a insurance for drivers process. So depending on the gender and the age of the driver, we're going to put a message into a variable with the name of MSG, short for message. If we have a male driver who's 21 or under, then we're going to put in the literal young male driver into MSG. For a female driver, 19 and younger, we will put in the literal young female driver. For elderly drivers, the condition would be that they are 65 and older, either gender. And for all others, we will put in the literal other driver into the variable MSG. Here's a possible solution. We're modeling our solution. This would not be the full program. We input the gender, we input the age. Then the first one is asking for males who are less than or equal to 21, and we'd put in the message young male driver. The next condition is for females 19 and under, young female driver. And then greater than or equal to 65, elderly driver. Let's back up to the first one and take a look at the compound condition. We have the subject gender, the operator equal, the object M. We have a second condition, subject age, operator less than or equal, object 21. In both of these cases we have literals or constants as the objects. Fairly normal. They are connected with the logical operator AND. We will not spend a great deal of time on this. You are expected to read about it in the logic structures handout. Notice how each one of the conditions is enclosed in its own set of parentheses. This is not required in Visual Basic, but it is in C++ and I assume in Java, and it is in Visual Logic. So it is a good thing that Visual Logic requires it, because you will get used to doing that for next semester. Let's walk through a test case of somebody who's age 30, a guy. Well, let's run it. Age 30. We would expect to see the message other driver. Instead, we see a 0 because we never did put the words other driver into this. I could possibly do it here. And that worked. But let's take a look at the 16-year-old male driver. Let's see what happens there. We get the right answer. However, let's trace through. We input male 16. We put other driver in the message box. The condition is true. A male at age 16 would take the true side. But now what happens? Gender equals F? No, so we're going to take the false side. Age greater than or equal to 65? No, so we take the false side. So the net result is that there were two extra ifs that the condition had to go through. It is far better to have what's called a nested if to check for this situation. I can achieve that easily by just dragging the ifs, the selection structures. There. This is much more accurate. If our first case happens to be true, that it's a 16-year-old male, we will initialize the message, exit out of the selection structure, and put out the output. Yes, it's true that if we have a 40-year-old female, they're going to have to check the first if, the second if, and the third if before we get to the message other driver. For this reason, you would want to do a scientific study to find out which was the most frequently met condition and have it listed first. On the other hand, we really can't easily determine 40-year-old female in this case because we have a mixture of the ages. We have 21 for one and 19 for the other. So a 20-year-old female is considered an other driver, etc. So take a look at this. When you come back in the next session, we will pseudocode it.